beer, it's good for you.
Hello and welcome to the video. Within this video we'll be looking at the electrical costs for brewing, which are naturally under pressure more when energy pricing is higher than usual, like we experience right now. I will also be sharing some great hints and tips for reducing your electrical costs that relate to brewing too. So let's get into it. Firstly, let's look at breaking down the costs of brewing. Two very commonly used brewing systems worldwide are the Grandfather G30, which is rated at 2 kilowatts, and the Brewzilla 35, which is rated at 2.4 kilowatts. Element size will naturally give you more heating power, resulting in a faster temperature ramp-up. Ramp-up times will of course vary depending on various other factors too, like the temperature of where you are brewing and the temperature of your water at the start. So let's get some examples going. Your brew starts with your heat up time to your mash water temperature, which is done at full power. It is estimated that a 2 kilowatt system will averagely manage this in 30 minutes, so in kilowatt hours the measurement of electricity usage, because this is just 30 minutes, this 2 kilowatt system will use 1 kilowatt's worth of energy. The equation here is shown on screen, but let me explain it. This is 2 kilowatts multiplied by 0.5, which is our 30 minutes being half an hour, resulting in 1 kilowatt hour. So that we can take a running log, I've added a 1 kilowatt hour symbol on the top left for the Grandfather as a visual reminder of power use so far, and I will do this for both systems so that we have a full running log. Let's now look at this same calculation for our Brewzilla. We can estimate that a 2.4 kilowatt system will averagely manage this heat up time in 25 minutes due to its extra kilowatts worth of power. The equation here is 2.4 kilowatts multiplied by 0.4166666, which is our 25 minutes as a percentage as an hour, resulting in the same 1 kilowatt use. Well, it's just a hair under 1 kilowatt, but it's so close we will call it 1. To calculate minutes in the hour as a percentage, you simply divide the time value by 60, so in this case you divide 25, which is our minutes of the heating, by 60. So the usage of both of these systems so far is just 1 kilowatt hours each. Let's now deal with the mash itself, and with a 2 kilowatt system is estimated to average at no more than 25% power, and this will be performed for 1 hour. So the equation here is 2 kilowatts multiplied by 0.25, which is our power level, and because this is a step for a full hour we can leave it at that with an end result of 0.5 kilowatts per hour's worth of usage. Let's now look at the same equation for the 2.4 kilowatt system, which will actually only need 20.8% of its power to maintain the same temperature. The equation here is shown on screen, and actually we are looking at 0.4992 worth of kilowatt hours here, but let's call it 0.5 because frankly it is really a hair's difference. So both systems now have 0.5 kilowatt hours added up top. Next we have the ramp up to the boil. Our 2 kilowatt system is estimated to manage this from mash out temperature within 30 minutes, and this will be performed at full power. So the equation here should be straightforward now, as 2 multiplied by 0.5 giving us 1 kilowatt hours worth of power usage. Whereas our 2.4 kilowatt system is estimated to do the same heating in 25 minutes. Our equation here is also very familiar at 2.4 multiplied by 0.4166666. Once more we have another 1 kilowatt hours worth of usage, and this has been added to our running total on top. And now lastly the boil stage, which is a case of maintaining temperature, but due to the higher nature of the boil, this will mean that a 2 kilowatt element will need to allocate 100% power for the duration of the boil to keep the boil. The equation here for our G30 is 2 kilowatts multiplied by 1, which is the boil power at 100%. Because this example is for a 1 hour boil, there is no further equation. More on this later in the video. Our 2.4 kilowatt Brewzilla is estimated to averagely use 83% of its power to maintain a full boil. So the equation here, seeing as in this example we have a 1 hour boil, is 2.4 kilowatts multiplied by 0.83, which is our percentage of power, which actually comes out at 1.992 kilowatt hours. But once again it's a small difference, so let's chalk it up to our total as 2 kilowatt hours. If we now do some simple addition of our running power usage count, you will see that both systems used an estimated 4.5 kilowatt hours for this average brew. The only difference shown really is that the higher powered system did it quicker. However, I should also mention that there is a missing variable here, which is heat loss, which would also benefit a higher powered system's numbers when estimating in this way, but I believe giving this a mention is enough. The data used here assumes a brew size of around a 1 keg batch brewed inside at a normal ambient temperature. Let me reiterate that this is just an example, but I did have a lot of assistance from people from within both Kegland and Grainfather to assist in preparing this data. So now that we know our consumption, we then need to look at what these levels of consumption will cost, and naturally this will vary according to where you live and the supplier used. I managed to find electricity data from earlier this year online that compared world energy prices and put them into US dollars for easy comparison, and that works well for us here, so here is a snapshot of that information. So quite clearly if you live in Canada then you are paying less than many, but let's take this at the German rate, which on this list is the most expensive. At 4.5 kilowatt hours worth of electricity usage, this is simply the equation of 4.5 multiplied by 0.429, giving a total cost of just under $2. To put this in perspective, in the US at Starbucks $1.93 will buy you a single coffee on their menu out of almost 100 different coffee types, which is of course the most basic one according to the data I found online at the time of researching this video. Let's not forget though, this is the most expensive price for electricity on this list. If like me though you live in Norway, then that brew will cost you just over half a US dollar at the time these electrical prices were current of course, which will not really buy you much at all of anything here in Norway. Also keep in mind that Norway is one of the most expensive countries in the world to buy commercial beer, so homebrewing in Norway is a no-brainer. Check with your energy supplier for your current kilowatt per hour rate and do the math based on these estimates, or if you want to be more precise then you can obtain electrical meters that will show you your electrical draw for any device plugged into it. You are likely to see that the numbers presented here are actually an overestimation. Now that we all know that the brewing side can be very cheap, I wish to warn you that some types of products within the homebrew market actually draw an alarming amount of electricity for what they are and really should have a warning about this stamped on them. Then after this we will look at other ways of saving money rather than just avoiding these products. Thermoelectric heating and cooling units are typically up to 10 times more power hungry than compressor-based or heating element units. Thermoelectric components are very cheap to add to products, but that is where the saving ends. So it's worth spending a bit more on a product that doesn't use thermoelectric heating or cooling, as it will pay for itself in the long run. Shown on screen are a few examples of these electrically hungry products from the homebrew market worldwide, but sadly as I understand it they are not the only ones. Here are some further money saving tips which will certainly add up over the course of time into good savings. Firstly, when it comes to water you use for brewing, it is best to fill your brewing system with sponge water heater the day before you brew. Water will usually be colder than ambient temperatures, so by doing this you will be heating on brew day from a higher temperature. Large savings can be found if you reduce your mash and boil times. Many commercial breweries only mash for 40 minutes and the modern day brew time of 30 minutes is also commonplace for professionals. Not only will you be saving money, you'll also be gaining flavour. Also, it is now common knowledge that there is really no need for a boil that is very rigorous. This is an old brewing myth that frankly seems stuck with some, just like the 60-minute boil. If your system has boil control then this is very useful here, but various systems have their own methods too. Insulating your homebrewing system with a jacket on the outside will make a very noticeable difference when it comes to heating power. Be sure to use the right material here. Most brands like Kegland and Grainfather have their own jackets for each system at a very reasonable price, and the assurance that what you are buying is not only not going to melt, but that it is also going to insulate very well. Go big, brew smaller. I do like this catchphrase, but basically what it means is that by using a larger brewing system with a larger, more powerful heating element, you may think that you are using more power, but it's all proportional. If you use a larger heating element based system for a smaller batch size, then not only will you be saving time, but you'll also be minimizing heat losses too, resulting in far greater efficiency, and thus a cheaper electricity bill. It's a little bit like taking a small engine car up a steep incline. It can manage it, but something more powerful will be faster and more efficient at the task because it's not being run at its maximum power. Then lastly, if you brew according to the weather, you can then minimise your overall energy use. This will be lagers when it's cold, ales during moderate weather, and the use of cake yeast during your summer. It makes sense really. I do hope you found this useful. Now, as much as I feel that I've put forward some pretty good energy saving tips for brewers here, I believe that there just has to be more that can be added. So if you have anything you would like to share with the brewing community, then please share the information within the comments section of this video. Please also feel free to let me know if you found this video useful too, or if you have any feedback of any nature. I read and reply to all comments. I do hope that you found this video useful, informative and interesting. If so, why not consider liking and subscribing? For further support, you can join the channel's Facebook group, and if you would like to support the channel, then check out the channel's merchandise store, as all profits go back into the channel. Until next time, happy brewing!